Okay, I'm back, and now we're going to do the lab on reflection and refraction. So the only measuring device that we used in that lab was the ruler. So there might be a question where you have to measure perhaps the focal length of a mirror or the focal length of a lens. So something where you have to measure something with a ruler. Okay, what would be the concepts that we talked about in that particular lab? Well, it was reflection. So you should know what the definition of reflection is. All right, and then we did reflection by a flat mirror. And one thing that we noticed was that the angle that light goes into a mirror is the same as the angle that the light comes out of the mirror. Remember, we did the thing with the string? We also noticed that your image appears to be behind the mirror, the same distance that you are in front of the flat mirror. Then we had the concave and the convex mirrors. So you should be able to draw a picture of a concave mirror or a convex mirror. If you should be able to illustrate what happens to light when it hits a concave mirror. Where does it go? Or what happens to light when it hits a convex mirror? So if you go to the lab, I've got pictures of all of this. Okay, then we did an experiment where you took the convex mirror and you held it in front of your face and you looked into it and you made note of how big was your face, and then was it right side up or was it upside down. And then we did the same thing with the concave mirror. So review those results from the lab. Okay, then we did refraction. And I showed you that in the same way you could have a flat mirror, you could have a flat piece of plastic, and it was a piece of plastic that was square shaped and was about that thick, and then you looked into it and you put a pencil behind it, and then you rotated the piece of plastic and you noticed that the pencil was broke. So that was an example of refraction. Okay, then we did a experiment where we had the converging lens and then the diverging lens. So how did we experimentally measure the focal length of the converging lens? Well, we took it outside and then we held it up so that the sunlight went through it, and then we measured the distance down to the ground where there was a bright spot of light, and then that distance would have been the focal length of that particular lens. And then you should have tried it with the diverging lens. And what happened? Nothing. Okay? Because what does a diverging lens do to light? It diverges it. So you wouldn't expect to be able to see the focal point for a diverging lens. But you could with the converging lens. Okay, then when we went back inside, we made a optics bench where we had a candle at one end, a lit candle. Then we put the lens in the middle, and then on the other side we put a screen. Okay, and then what you did was you moved the lens back and forth until you got a bright image of the candle flame on the screen. And then you measured the distance from the object, which was the candle, to the lens, so that would be O. O for object. And then you measured the distance from the lens to the screen. That would have been I, the image. And then you could take those two numbers, plug it into that formula that's there under math. So 1 over f equals 1 over O plus 1 over I. And you could solve it for f, which would have been the focal length of that particular lens. And then you compared it to what it was when you did it outside. So there could be a math problem that goes with this lab where I give you that formula, 1 over f equals 1 over O plus 1 over I, and maybe I'll tell you the f, and maybe I'll tell you the O, and you have to calculate the I. Notice how similar it is to the formula that we used for total resistance in parallel. It's the same principle. So you got to take 1 over F, calculate that, 1 over O, and 1 over I. So it takes some practice to be able to do this. Okay, let's go to our next lab, which was on interference and diffraction. So let's start off with interference. Now notice that there wasn't any measuring device for this particular one, and I take that back. Diffraction grating. So the diffraction grating would have been a measuring device. I don't know if we did it or not in lab, so I won't put it on the exam. But that is an actual device that's used to measure diffraction with. So we did interference, diffraction, and polarization. So let's begin with interference. We did interference by a ripple tank, and we did it using a PhET simulation. So if you go to PhET and then look for interference, you're going to find one of the simulations is basically a ripple tank. It's the one that has the two faucets that are dripping. And then each one causes a ripple, and then where the ripples come together, they're interfering with each other. So I would want you to know what constructive interference is and what destructive interference is. Okay, and then we also did the Newton's rings apparatus. So could you explain on the exam how the Newton's rings worked? How did it cause the light to be interfered with? And then we also did soap bubbles. So made soap bubbles and looked at the rainbow of colors that were on the soap bubble. So could you explain on the exam what caused those different colors on the soap bubbles? Alright, then we did diffraction by a slit. And I want you to know, how is the width of the slit related to the wavelength of the light or sound that goes through the slit? So under what circumstances, when the wave goes through the slit, will it spread out? And so it has to do with the size of the slit, and it has something to do with the wavelength of the wave. Make sure that you know that for the exam. And then we talked about polarization. So could you explain to me how does a polarizer work? So Polaroid sunglasses are made of Polaroid. So I have a picture in the notes showing what a polarizer looks like. And then I showed what sunlight looks like, how sunlight is polarized, or actually it's unpolarized. And then when it bounces off the ground, something happens to it, so that when it goes through your sunglasses, something happens to it. Okay? And then we also talked about what would happen if you got two polarizers that are aligned with each other. And then we talked about polarizers that are like this. Okay? So you might want to review that part. Alright, so I'm going to stop the video here, and when we come back, we're going to talk about yet another lab.